Hello everyone, welcome to yet another practice video on CSE 260. My name is Ramkrishna Shaha and I am one of your instructors of this course. In this video, I'll be showing you some practice problems on the arithmetic operations of 2's complement numbers. So let's get started. Before I move on to the practice examples, I want to do a quick recap on the conversion between decimal numbers and its 2's complement form. To convert a decimal number to its corresponding 2's complement form, we first need to check if the decimal number is a positive or a negative one. If the given decimal number is a positive one, we just need to convert it to its corresponding binary form and then perform a sign extension operation. However, if the given number is a negative decimal one, we have to do a few additional steps. At first, we need to convert the number into its corresponding binary form and then also perform a sign extension. After I'm done with step 2, I convert the binary number which I got in step 2 and then perform a bit inversion on each and every bit of the binary number. When I'm done with bit inversion, I add 1 to the answer and then I get my 2's complement form of the original decimal number. I would like to request everyone to pause this video and think what I just said. Now let's move on to our first practice problem. In this example, I am asked to add +3 and +4 in 4-bit 2's complement number system. And also, I need to show that if there is an overflow or not. Let's see how we can do it. Since +3 and +4 are both positive numbers, so to convert these numbers to their 2's complement forms, I do not need to do the extra bit inversion and addition of one step. In short, to convert this to their 2's complement forms, I just need to find their binary forms. And their binary forms are equal to their 2's complement forms. So let's see how. If I convert +3 to its binary form or 2's complement form, I will get 0, 0, 1, 1. Since this is a positive number, this is also my 2's complement form. To convert +4 into its binary form, I get 0, 1, 0, 0. Again, this is a positive number, so the binary form and the 2's complement form is the same. So I'm writing here 2's complement form. Now, I will add these two numbers the same way I did in my previous videos. That is, I will add each corresponding digit from the right and then gradually move to the left. When I add 1 plus 0, I get 1. When I add 1 plus 0, I get a 1. When I add a 0 and a 1, I get a 1. When I add 0 plus 0, I get a 0. From this answer, you can see this is also a positive one because the first digit is a 0. Since this is a positive number, when I want to convert it back to its decimal, I get a value of +7. So my answer is +7. There are two ways through which I can know that an overflow has occurred or not. The first is there can never be an overflow when I add two positive numbers and I get a positive number. So if I added these two positive numbers and I had gotten a negative number here, that would show that I had an overflow. The second way with which I can understand that there has been overflow or not is through the range. The range of a 4-bit 2's complement number system is from -8 to +7. So as you can see, my +7 is in this range. So there is no overflow. Let's check the answer. It is correct and there is no overflow. Moving on to the second example. In this example, you can see both my numbers are negative numbers. That means in this case, I will have to do the additional step of bit inversion and adding 1. At first, I will need to convert -2 to its corresponding decimal form. If I convert -2 to its corresponding decimal form, I get 0, 0, 1, 0. And this is in the decimal form. And this is a minus. If I want to convert it to its corresponding 2's complement form, first I will need to invert all the bits. If I invert all the bits, I will get the first bit 0 will become 1, the second bit 0 will become 1, the third bit 1 will become 0, the fourth bit 0 will become 1. And this is not my 2's complement form. There is one additional step. That is, I will need to add 1. If I add 1, 1 plus 1 is 0 and a carry of 1. 1 plus 0 is 1, 1 and 1. So this is my corresponding 2's complement form of -2. Let's find the 2's complement form of -6. First, converting this into its corresponding binary form, that is minus of 0, 1, 1, 0. This is the binary form. Now, for 2's complement form, I again need to invert all the bits, then add 1. If I invert the bits, the 0 becomes 1, the 1 becomes 0, the 1 becomes 0, and the 0 becomes 1. And then I need to add 1. 1 plus 1 is 0. I get a carry of 1. 1 plus 0 is 1, 0, 1. In the last step, I will need to add the 2's complement value of -2 with that the 2's complement value of -6. Let's do the addition. 0 plus 0 is 0. 1 plus 1 is 0 and a carry of 1. 1 plus 1 is 0 and a carry of 1. If I add 3 ones, I get a sum of 1 and a carry of 1. If you remember previous videos, during 2's complement additions, if I get an extra 1 as carry out, I used to discard that. So in this case, I will discard this out. Now my final answer is 1, 0, 0, 0. So do you think an overflow has occurred here? Pause this video and think for a while. No, there has not been an overflow in this case, because I am adding to negative numbers. This is a negative number and this is a negative number. I am adding to negative numbers, and in the answer I am getting one negative number. I am understanding this is a negative number by the first digit. Since the first digit is 1, I can say this is a negative number. So there is no overflow. To convert this value into its corresponding decimal form, I will need to do a bit inversion first. Now let's convert this 2's complement value into its decimal form. So to convert this value to its corresponding decimal form, I will need to go through a few additional steps. At first, I need to perform a bit inversion on this number. If I perform bit inversion, I will get 0, 1, 1, 1. And then to convert this to its binary form, I will need to add a 1. If I add a 1, I will get 1 plus 1 is 0 and a carry of 1. 1 plus 1 is 0, carry of 1. 1 plus 1 is 0, carry of 1. 1 plus 0 is 1. This is the binary value of this 2's complement form. Now it's very easy to convert this binary form into its decimal value. The decimal value of this binary form is 8. And since this was a negative number, as we saw before, this will be -8. If the answer I got here was a positive one, I could have directly converted it into its decimal form. Since it was a negative one, so I had to go through these additional steps. My answer is thus -8. So there is no overflow because of the reason I just mentioned before. That is, I'm adding to negative numbers and I'm getting a negative number in the answer. Another way to check if my answer is an overflow or not is to look at the range. If you remember, the range of a 4-bit 2's complement number system is from -8 to +7. Since -8 is inside this range, so I can say that there is no overflow. Let's look at the third example. This is a positive number. Let's convert it to its binary form, which is 0, 1, 0, 0. Its 2's complement is the same, which is 0, 1, 0, 0. This is a negative number. So first, let's convert it into the binary form. If I convert 7 to its binary form, I get 0, 1, 1, 1. As this is a negative number, to convert it to its 2's complement form, I need to perform a bit inversion first. If I do bit inversion, I will get and then add 1. This is my 2's complement form of -7. Let's add this and this. 0 plus 1 is 1, 0, 1 plus 0 is 1. 1 plus 0 plus 1 is 1. This is my 2's complement form. So please pause this video and think if there has been an overflow or not. No, there has not been an overflow here. The first reason is when you add a positive number and a negative number, there can never ever be an overflow. So as you can see, this is a negative number. Let's convert it back to its decimal value. First bit inversion, then adding 1. I will get 0, 0, 1, 1. This was a negative number, so I add a minus here. If I convert this to the decimal value, I get minus 3. My answer here will be minus 3. So as you can see, this also falls in my range. My range is from minus 8 to plus 7. Is there an overflow? No, there is no overflow, because I am adding two different side numbers, or a positive number and a negative number. When I add two different side numbers, there can never ever be an overflow. Moving on to the next example. Let's write 5 in 4-bit 2's complement number system. As this is a positive one, plus 5 will be 0, 1, 0, 1. This will be the binary, also the 2's complement form, as this is a positive one. To convert plus 6 into its 2's complement form, it will be 0, 1, 1, 0. This is also the 2's complement form. Let's add these numbers. 1 plus 0, 1, 0 plus 1, 1, 1 plus 1 sum 0, carry will be 1, and I get a 1 here. You can clearly see that there has been an overflow here, because I am adding two positive numbers and I am getting a negative number here. This is a negative number because I am getting a 1 in the MSB. So I can clearly say there has been an overflow. Let's convert this to its corresponding decimal form. Let's do the bit inversion first. 0, 1, 0, 0. Let's add 1. This was a negative one, so minus of this. If I convert this to decimal, I get minus 5. So if I add plus 5 and plus 6, the answer I am getting here is minus 5. But if I added plus 5 and plus 6, I would have gotten plus 11. So as you can see, this is an overflow and there has been an error. So you can just stop right here in this step and say there has been an overflow and declare that there will be an error in the answer. Let's check our answer. As you can see, our answers matched and there is an overflow. Next example, and the last one. I am asked to compute minus 3 and minus 6 addition. Let's do it. When minus 3 is converted to its 2's complement form, first the binary form is 0, 0, 1, 1. The 2's complement form will be first bit inversion, that is, and then adding 1. I get 1, 1, 0, 1. This is the 2's complement form of minus 3. For minus 6, this will be negative here. This will be 0, 1, 1, 0. Bit inversion next, plus 1. So 1 plus 1 is 0, carry of 1, 1 plus 0 is 1, 0 and 1. This is the 2's complement form of minus 6. Now let's add these two numbers, this one and this one. So 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0 and a carry of 1, so this will be 1 right here. So since I got an extra 1, I will have to discard it. This will be discarded. My final answer is 0, 1, 1, 1. Pause this video and think if there has been an overflow here or not. Yes, there has been an overflow because I'm adding two negative numbers. This is a negative number and this is a negative number, and I'm getting a positive number here. So there has been an overflow. I can stop right here. I'm repeating, this is a positive number because there is a 0 here, and these are negative numbers because these are ones. So when I added two negative numbers, I got a positive number, which is not possible. So I can say there has been an overflow and the answer is an error. If I had added -2 and -6, I would have gotten -9. But if you convert this to its corresponding decimal form, you will not find it as -9. Let's check our answer. So as you can see, our answers matched. So this was the last example of arithmetic operations on 2's complement number systems. In the next video, I will be showing you some arithmetic operations on 1's complement number system. But before I go, I would like to request you to pause this video and have a quick look at the summary of overflow in sign numbers so that you don't make a mistake in the exams. Thank you everyone, and see you next time.